we are going to start a unit on graphing. And as we do that, I wanted to go back to the features of graphs, which you guys learned in Algebra 1 and Algebra 2, and just do a brief review of those because we're going to be looking at several different types of graphs and we're going to be analyzing these features on those graphs. So the first one we want to remind ourselves of is domain and range. So domain, all the possible x values for a graph. And when you look at domain, you always read it from left to right because domain always is smallest to biggest. The smallest x values are over here on the left. The largest x values are over here on the right. So largest to smallest, left to right. Range is always going to be read from bottom to top. So range is all the possible y values, and you always read the range from bottom to top. Now in this particular graph, my domain, my x values, I pay attention to these arrows right up here at the top, and I can see that not only are they going up, but they're kind of going off to the right and to the left. So my graph is going on and on forever to the left, and also on and on forever to the right. So the domain is negative infinity to positive infinity. And if you want to abbreviate that, you can use the all real number symbol, which is like an R with two sticks. Now the range is bottom to top. So look, here's the lowest that this graph goes, and then those arrows tell me it's going on and on forever up. So when I do this, I want to focus in on the y value right here. Range is the only time you're ever going to pay attention to y values with these features. So this graph, the lowest that it goes is negative 6.125. Okay, and you can see that I have a square bracket right here because it actually touches negative 6.125 right there. That's included. And those arrows tell me it's going on and on forever up. So it's going to go to infinity. And you'll remember from last year, we never include infinity because you never actually reach it. Okay, the next feature we want to look at is intercepts. Our x-intercepts are where y equals 0. Y is the same thing as f of x. So I could say that f of x equals 0. These are called roots. These are also called zeros. When we do this in your calculator is going to use the term zeros. And if you took the equation that was associated with this graph and set it equal to 0 and solved it, the solutions that you get would be your x-intercept, because you would have a graph set equal to 0, and that 0 is in the y position or the f of x position. So when I set the equation equal to 0, what I find are my x-intercepts, which you can see right here on the curve. My x-intercepts are at 0.5, 0, and negative 3, 0. So some books, some teachers will have you write those as points. Some will just have you write them as numbers. I believe that Delta Math just asks you to write like negative 3, comma, 1/2 or 0.5, and you just type in the x values of the points. The x-intercepts are used to help us find out where our function is positive or negative. And you remember from what you did last year, the positive part of the interval is where it is above the x-axis, which is here. And the negative part of the graph, the interval that's negative, is where it is below the x-axis, which is here. So it doesn't matter whether it's going up or going down. What matters is whether it's above or below the x-axis. So in the positive part, you can see that I colored this area blue and I colored this area blue. Both of those are above the x-axis. So I am going to write two intervals. And again, our intervals are going to go from left to right because they're always going to go smallest to biggest. And our intervals are based only on our x values. So I'm going to scribble out the y values. The y values we do not use when we write our intervals. We only use our x values. Okay, so this arrow tells me it's going on and on forever up, but also to the left. The farthest to the left that it goes, the smallest x value is negative infinity. And this one, you can see that it stays positive until right here. At this point, the y value is 0. It's no longer positive. So at negative 3, it stops being positive. And I'm going to put an open parentheses there open interval parentheses, because that tells me that the graph is not including -3, because at -3 it's actually equal to 0. It's not positive or negative. All right, I'm going to put a U for union, meaning I'm putting these two intervals together. And then I'm going to put this interval, left to right, smallest to biggest. The farthest to the left this one goes is 0.5, or you could use 1/2. And it goes on and on forever to the right, which is to infinity. All right, now let's look at our negative interval. The negative interval is this whole red area on the bottom. It starts being negative at -3, but remember, -3 is not going to be included because -3 is equal to 0. It's not positive or negative. And the same thing with 1/2, or 0.5 right here. The y value is 0, so it's not positive or negative. I'll type 0.5 like they have on the screen, 0.5. So our negative intervals in red and our positive intervals in blue. Okay, the y-intercept is our other intercept. Y-intercept is right here where x equals 0. And again, some people may have you write that as a point, 0, 3, like you can see right here. Some people may just ask for the y value of -3. So you just have to wait and see what the particular computer program or particular professor is asking for. And if you have an equation written in standard form, the constant term will be the y-intercept. So whatever this equation was, y equals 2x squared plus 5x minus 3, right? That -3 right there matches this -3 right here. The constant is the one that has no x on it. So when it's written in standard form, I would get this. The reason why is because that's where x equals 0. And if I put 0 in for all of my x's, the only thing that's not going to 0 away is this one. Both of those are going to become 0. And so what I'm going to be left with is -3. That only works if it's in standard form, but if it is in standard form, that's a quick way to find your y-intercept. Okay, a point that is lower than all of the points around it is called a relative minimum. So this particular graph has a relative minimum value. A point that is higher than all the points around it is called a relative maximum. This particular graph does not have a relative maximum. It's going on and on forever up in both directions, but at no point does it have like a hump going this way. That would mean that it has a relative maximum. A valley tells me that it has a relative minimum. So here's your relative minimum value. You guys notice this is a parabola. That's the vertex. And so the x value of -1.25 might be what they're asking for. Where is the relative minimum? The value of -6.125 might be the value that they're asking for. That tells you what the relative minimum is. So this tells you where the relative minimum is located. This tells you what the relative minimum is. All right, relative minimums and maximums are used to help us find intervals of increasing or decreasing. Okay, so intervals again are only based on your x values. So I'm going to scribble out that y so that we don't pay attention to it. Okay, increasing. Think about the word increasing from what you remember in your past, what you remember from life or your English classes. Increasing means going up. So this whole interval right here is increasing. Part of it's positive, part of it's negative, but that doesn't matter. As I read the graph from left to right, this whole part is going up. Now, decreasing is the opposite. Decreasing means going down. So this whole interval right here is where the graph is decreasing. As I read the graph from left to right, that is where it is decreasing. Okay, so let's write what those intervals are. Again, we always write our intervals from left to right, smallest to biggest, and we only focus on x values. So look where I have it colored gray. Where it starts increasing is right here, but actually at -1.25, it is neither increasing nor decreasing. It just hovers for like a minute or a second, and then it's going on and on forever to the right to positive infinity. It will keep increasing because that arrow tells me it's going to keep going in this same manner, continuously up and continuously to the right. Decreasing is this orange part over here. So again, I'm going to go left to right. This arrow tells me that the farthest left it's going to go is negative infinity. And it's going to continue decreasing, decrease, 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 decrease until it gets right here. and then it's going to turn and it's going to start increasing. So again, I'm going to use that negative 1.25 point, but I'm going to put parentheses, an open interval, because actually at negative 1.25, it is neither increasing nor decreasing. Okay, so that one that we just looked at was a parabola. This one that we're going to look at is a cubic, and we're going to learn how to apply these words to any particular function that we might look at. Okay, so domain, left to right. And again, you can see that this one is from negative infinity to positive infinity. It continuously goes to the left, and it continuously goes to the right. Range is bottom to top. All right, so I've got the bottom and I've got the top. Well, this one works out to be negative infinity to positive infinity as well, because you can see from the arrows, it's going on and on forever up and to the right, on and on forever down and to the left. So negative infinity to positive infinity on both of those. All right, our intercept values. So negative 2.186 is rounded, that's this one. 0.686, that's rounded, that's this one. But this one right here, what would be the x-intercept that's right here? That one would be negative 1, 0. Notice that they all have 0 where for y, because the x-intercepts occur when y equals 0 or when f of x equals 0. Okay, let's find our intervals of positive and negative. Let's do positive first. Okay, what does positive mean? Positive means it's above the x-axis. So this whole area right here is above the x-axis. And this whole area right here is also above the x-axis. All right, how about negative? Negative means below the x-axis. So that's this area and also this area. So we're going to have 2 intervals for each of those. All right, left to right, smallest to biggest, only looking at the x values. So this first blue one, it starts at the x value of negative 2.186, and then it continues to the x value of negative 1, not including either one because it's equal to 0. And then I'm going to union that with the one that starts at 0.686, and it's going to go on to infinity. This arrow tells me it's going on and on forever up, but it also is going to the right. All right, my negative intervals. All right, well, here's the first one. This arrow tells me it's going on and on forever down, but also to the left. So it's going to start at negative infinity, and it's going to stay negative until right here. That's negative 2.186. Oh, can't see my negative very well. And I'm going to union that with this interval, which starts at negative 1 and goes over to 0.686. So there's my positive and my negative intervals. All right, the y-intercept is where x equals 0. All right, so let's see what that would be if I write that as a point. That's going to be the point 0, negative 3, because x is 0. All right, increasing and decreasing. Those come from my relative maximum right here at the top of the hill and my relative minimum right here at the bottom. So I'm going to turn my pen gray and I'm going to look at increasing. Increasing means going up. So it's increasing here and it's increasing here. All right, and decreasing means going down. Decreasing is here. Okay, once we've identified that, we can write the intervals. So this interval first, left to right, starting here, negative infinity, and on up through, which one of these numbers should I pick? Well, I should only pick the x value. So negative infinity up through negative 1.667. And I see that there's another gray one, which is here. And again, I'm not going to look at that y value. I'm going to focus on the x value, 0 to infinity, because it goes on and on forever, up and to the left, to the right. Decreasing, just one decreasing interval this time, focusing on those x values. And there's my interval for decreasing.